everybody, I'm Lindsay Pease, as they just introduced, and I have the perhaps unenviable task of being the last talk of what I'm sure has been a really great day, but I will also try to keep this kind of light, fast-moving, just to try to keep all of your energy up so that, I don't always like to be the one standing between you and whatever the after-conference activity of choice might be. And today I am going to be talking about what we've seen after the first 2 or 3 years of drainage plots that we have at the Northwest Research and Outreach Center in Crookston. It's no surprise, and you guys all heard Daryl talk, rainfall is irregular and unpredictable. But it's one of those realities of farming. There's nothing you can do about that. But one of the things you can do is manage your water. And drainage water management and subsurface drainage is a large-scale infrastructure change. This is not something that you just take on willy-nilly. You don't dabble in it. If you're going to do drainage, you really commit to it because it is a big investment. And so that's really the whole idea behind me doing some of this research, is seeing just what happens when we add drainage in a large scale. We have really rich clay soils in the Red River Valley, and those are the types of soils that really benefit from drainage. And this is a particular map that some of the folks that are doing drainage research all across the Midwest have come up with. And basically, they've said this watershed in this area is one of the most suitable for drainage anywhere. But we all know that soils are only part of the story. And we also are dealing with a little bit less rainfall than they get in other parts of Minnesota. So sometimes that kind of leads to the question of how much do you need how much rainfall do you need for this drain tile to actually pay off? The other reality of farming up here is that we are in one of the coldest agricultural areas of the entire United States. And that affects our short growing season, that affects the fact that we get a lot of our water coming through in snowmelt. And we're going to kind of talk about all of this throughout the presentation. But the other thing that this means, that we are in one of the coolest agricultural regions of the United States, is that I get to claim that I have the coolest drainage plots in all of the country. And no offense to my colleagues at NDSU, but Crookston is cooler by annual average temperature than Fargo. So right up north in Crookston, we have the coolest plots. The point of these plots were not just research. We also wanted them to be large scale. I wanted to be able to look at, with full-scale farming equipment, what are the effects on nutrient cycling and yields, and also runoff. And we also wanted to put them somewhere that would be highly visible, because a lot of you already know, and you've been around, you know that drainage is beneficial. But there's a big component of this work too that's outreach to the public and trying to convince them why drainage is beneficial and that it's not as harmful as a lot of people think that it is. So way back in 2019, September of 2019, we had all the drain tile delivered on this field, ready to be installed, and then we had to wait. Because in one picture, I can show you why this particular field needed drain tile. It was too wet to install the tile drains. So we had to wait all the way until mid-October to actually get those drains installed. And it's really made a huge mess of the field. We needed not just the drain plow, there needed to be a tractor to pull the drain plow and pull those laterals in underground. And, and there's large excavators driving across the field to be able to install the lift station. So this really did make a lot of soil disturbance and a lot of soil compaction from the installation. But we did get this up and running by November of 2019, and in retrospect, so glad we got this done in 2019 because we all know what happened in 2020. And but just a little bit more about the location and layout. This is a 60-acre field, and it is right by the Crookston Sports Center, if anyone is familiar with Crookston area. We have a lot of traffic coming by this field every day. And it's a silty clay loam soil, and the tile are installed about 50 feet apart and at a 1 foot or 3 feet depth, 1 meter deep. And what we did is we designed this field as if we were going to drain the whole thing. So the mains are all sized as if we were going to drain the entire 60 acres, but we only ran laterals in 2 sections of these 4. So we kind of broke it up into 4 15-acre chunks so that we could look at just those really big differences between our drained plots and our undrained plots. So I mentioned, in 2020, we had a lot of rainfall. And what I have up here is showing you all the rainfall in a month-to-month basis that we experienced up in Crookston. And I don't actually have this starting from calendar year to calendar year. I have it starting in October of 2019, because the reality of farming here is that we start banking water for the next growing season all the way back once that crop comes off the previous fall. So we start banking water for 2020 in October of 2019. And you can see just how we got a lot of rain that fall. That's where I showed you all that water was ponding in that field. And then, we have winter happening, and June 2020 was so wet. We had, in July, we had way more water than average, and it drowned out a lot of crops, especially around Crookston. And then we get to the next year, that next fall. After that crop comes off, it's like somebody just shut the valve completely off. Now I've added the year of 2021 onto this graph, and I always think it's so shocking to see just how little water we got compared to 2020 that we had during our exceptional drought year of 2021. You can see it just didn't rain. And we really had no water to speak of to support that crop. So of course, while it was really great, we're like, yeah, it's raining a lot. We had drains in 2020. Then we had no water to speak of to drain in 2021. And then of course, we had this past year, 2022, where we start to get rain again. We got a little bit in the fall, and we actually had most of our rain falling in this April and May timeframe. So actually, most of the water was falling before the crop even got in. And then again, you start to see that water tailing off by the end of the growing season. And the one unfortunate thing, if we have all this water in April before we have any crops going on, is we end up with a lot of surface ponding and water running off the surface. And the other reality of draining is that we do have lift stations, but we didn't have the lift stations turned on because we didn't want to contribute to downstream flooding. So this is on the drainage plots. We saw surface runoff on our drainage plots in early 2022 because we weren't draining the field, and we saw surface runoff impact from that. So that's also kind of a reality of like a lot of our water is coming in this early spring period. So we're going to kind of talk about all of this in terms of how that affects the soil. And what we see, these are 2 graphs that show our soil moisture kind of throughout those 2 years, 2020, which is our really wet year, 2021, which is our really dry year. And it might be a little bit hard to see, but if you're looking right on the top graph, you can actually see the moment when we turn our lift stations on and the soil moisture in the top 6 inches starts to spread apart. And we had a lot of rain again through that June and July period. And at the top, we had our undrained plots carrying more soil moisture than our drained plots, which are on the bottom. And we were growing soybeans. We all know soybeans don't like to have wet feet. So just that little bit of moisture reduction in our drained plots should be really beneficial when we look at yields. In 2021, you can see those lines are still kind of trending together, but we really just have nothing to speak of, no water left. It's not at 0 because some water is always left really tightly between soil pores that the plants can't access, but that's pretty as close to 0 as you're ever gonna get. So now the question you've all been waiting for is, how were our yields? Well, compared to our 2019 baseline, this was before we had any drainage out in the field. We had wheat in 2019 and during our drought year of 2021. And what you can see, these are just maps straight off the yield monitor for you. So not necessarily as scientific as some of the numbers I'm going to show you later, but visually you can actually see how if you're looking across this whole field, in 2019 it's all pretty even. In 2021, the far left side and then the part that's kind of the third section, the third slice here, those are our drained plots. So those are actually yielding a little bit poorer than our undrained plots. The first reaction is always that, oh, well, we didn't have any water. We over-drained those sections. But I'm gonna pause for a second, and I'm also gonna remind you of all that soil disturbance that we did in those drain plots when we installed this back in 2019. I think there's a good possibility that this was actually soil disturbance showing up as opposed to a lack of water, because what I showed you with those soil moisture graphs is those were trending pretty much the same amount of zero all through that year. So what was different is the soil disturbance. 2020, kind of going back in time, we had soybeans in 2020 and 2022. And what you see here, you see those red lines that go horizontally across this field. Those are the surface ditches that cut across the field. So that's where the water's collecting. Again, soybeans having wet feet. But you can see more green in our first and our third, which is where our drained plots are. 2022, a lot of our water happened before we actually even had the lift stations turned on. So we kind of ended up about even in 2022, back to kind of all that field looking the same again. And one thing to note that kind of furthers that theory of looking at compaction as it affects crop establishment is back in 2020, this was a section that was right by the lift station. So this is one of the most disturbed areas that we had. That's this upper corner of the farm. And this is also where there's an access road and where we're always accessing this to collect all of our data. So there's a lot of driving happening in this part of the field. And you can see that we didn't get a really great soybean stand over there. We also didn't get a great soybean stand in our undrained plots, which was at the opposite corner of the field. This was kind of a low spot, undrained, and you can see kind of the same thing, but it's wetter. So it's compaction causing poor stand, and it's water causing poor stand in 2020. So we kind of see a little bit of both, and it's about kind of where are those trade-offs happening. When we pencil this out, though, we did come out ahead on our drained plots for soybeans in 2020. We definitely benefited from having those drained plots when we kept getting rain in June and in July. For wheat in 2021, again, we did take a little bit of a hit in our drained plots, but it's not quite as drastic as that 2020. It's not quite as big of a difference as it is in 2020. And then 2022, we're back to about even again. So, you know, one year, one's winning, the other year, the other side's winning, and then they're kind of evening out. So no definitive answer yet on did drainage make us money, but with more years, we're gonna keep doing this. And I think we have, you know, some good evidence showing that when it rains, we are making money off the drain tile. The other thing that we are doing on these drainage plots is we are soil sampling them 2 to 3 times a year. So we're kind of going to move away from kind of those yield impacts, and now I'm going to talk about what's happening in the soil. And what we're seeing in the soil is we're taking soil samples, especially these first few years, in the spring before anything gets planted, midsummer, and then in the fall after harvest. And we take samples a lot of different places in the field, about 16 places, so it's almost a one acre represented by one sample. And then those get kind of mixed together, and we can get a good look at what's happening with our nutrients. Now, the one other reality of doing all these samples is that GPS on your phone is not as accurate as you think it is, and We did hit one of the drain tiles this fall when we were soil sampling, because we sampled down to 3 feet, and we successfully found one with the probe. We were able to patch it and fix it, but to commemorate the event, my technician who was out with me, I was out that day, I picked the spot, she dropped the probe, and we punctured the drain tile, and now I have drain tile earrings to commemorate the event. She made earrings out of the piece of drain tile that we pulled up out of the ground that day. So earrings by Prinsco, great jewelry. Okay, so what can the soil tell us about drainage? These graphs are a little bit hard to look at right up front, but I'll walk you through it. I know you guys have been paying attention a lot today, so bear with me. At the top, we have our undrained plots, and underneath it, that yellow, that's the drained plots. And you see 2020, we have no difference. This is kind of our baseline level, not any difference at all between our nitrate levels between the two drainage plots. And the top bar is the top foot, then we go to the second foot and the third foot. With these graphs, these box and whisker graphs, I like them because they show you the spread. They show you how much variability we saw across those 16 samples we took. And you can see they're all trending pretty similar to one another in 2020, spring 2020. Once we had 2021, which was the full calendar year of 2020 when we had all of that rain, you actually start to see that in our drained plots, we had less nitrogen left over in our drained plots than our undrained plots. You can start to see that moving downward from the top foot. And the second foot, the same thing. And then we're about even again once we get to the third foot. Then we had a drought, and in the winter between harvest and planting, we took samples again. So this is what was left in the soil after the drought. And we actually see a lot of that nitrogen moving downward in our drained plots compared to the undrained plots. But both sections really had a lot of nitrogen moving downward, but more so, it was pulling it downward a little bit more in our drained plots than our undrained plots. Differences in the cycling for these 2 years. I'm kind of checking the time here. I don't want to leave you all here too long. This is the fun part where we get to talk about my least favorite subject in school, which is chemistry and the nitrogen cycle, but I put pretty pictures on it, so I hope that helps. And we have 2 pools of nitrogen that we can pull from in the soil, organic nitrogen and inorganic nitrogen. Really, the difference between the two is that organic N is what is coming from animals or plants. That is manure and organic matter, so any plant residue. Those are contributing to this organic nitrogen pool. Over time, that organic nitrogen turns into inorganic N. But you can skip that step and just apply inorganic N in the form of that commercial fertilizer, your anhydrous, your urea, anything that's a synthetic fertilizer. Now you have microbes, and what they do with that inorganic N, they are converting it to 2 different forms of nitrogen, nitrate and nitrite. This is the form, so microbes have to turn that into the form that can be taken up by the plant and made into proteins. So that nitrate form is what actually gets turned into your yield. But different things can happen to that nitrate. Hopefully most of it gets taken up by the plant, but not necessarily. Some of it will leave by leaching, so that's moving downward in the soil profile, moving out to groundwater or into our tile drains. The other part of it, the microbes, if they're underwater too much and they can't breathe oxygen, they will breathe nitrogen, and they will metabolize that and then release nitrogen in a gas form. So this is obviously a little bit simplified, but this is kind of the basic processes that are happening when you add nitrogen to the soil. So what we're doing is we're measuring not only what's sort of taken up by the plant, I'm also measuring what's leaving by leaching in our tile drainage water, and we are also measuring what the microbes are breathing, so we can get a sense of where that nitrogen is going. So I made up a little quick checklist here so we can kind of keep track, tally over these last couple of years where we've seen that nitrate and the nitrite moving. When we talk about denitrification, that's what the microbes are breathing. So we kind of trap the air that the soil is breathing out, what their soil is releasing in a lid, and you can sample that and get a reading of it. What we see is that the undrained plots, the microbes are more underwater. They're going to breathe more of that nitrogen and release it as gas than in our undrained plots. The undrained plots were able to use more oxygen than the undrained plots, which makes sense. If they're wetter, they're going to denitrify more. Again, we have this uptake. What we did for uptake is we just kind of did a checkbook balance of nitrogen in the yield, so estimating how much nitrogen was in that yield we took off the field. And of course, again, a little bit higher in some years than others. So I kind of called that one a wash. It's up some years and down other years as to which pathway is kind of having more. The last category is leaching, and we are monitoring. We take one sample of drainage water every day of the year that there is drainage water. And we also are doing that out of the surface runoff too. That's why we have 2 lift stations, is to separate out the surface water from the tile water at this stage together. If you just had this on your field, everything could go into one bucket. But for us, we wanted to keep them separated so that we could actually say what's coming out of the surface runoff versus what's coming in the drainage. And as you would expect, we do see more leaching losses out of the tile drainage. This isn't surprising, isn't necessarily concerning to me either, but it's just one of the realities of having tile drainage, that a little bit of that nitrogen, as I showed you, it is moving downward in the soil profile. When you actually add numbers to this, that kind of lets you see the relative amounts that are leaving through these different pathways. And in 2020, which is our really, really wet year, we had more nitrogen taken off as yield in our soybean crop for our drained section. So that's, again, we had more yield, more nitrogen leaving that way. And that was the biggest pathway of loss. That's great. That means most of the nitrogen that we are putting on is actually getting to the plant. That's what we want. And when you look at the gaseous losses, that's a smaller portion. That's a much smaller piece compared to the leaching losses, which came out to about 48 pounds on our drained plots. But one thing to keep in mind on this is that those 50 pounds that wasn't nitrogen that we applied this year. This is soybeans. We didn't apply any nitrogen. So this is all nitrogen that was just stored in the soil that's cycling naturally. There's a little bit of a lag time between what you put on and what gets stored in the soil and what's leaving. In 2021, we saw a similar story for uptake, where we had more yields, we had more nitrogen leaving the field, but we actually had more losses through the air than we did through the tile in this really dry year. And that's because if it didn't rain, we didn't have any water moving, we didn't have any leaching happening. So we actually had that gaseous pathway being more of a piece of the pie in 2021, in our really dry year. But the total amounts of nitrogen, again, you still see that most of what's leaving is leaving in the plant, and that's good. So what can we kind of conclude? What did we learn from all of this? Well, we did learn that drainage boosted yields in 2020, our really wet yields, but not in 2021. And I think that it is probably that compaction and the soil disturbance that we saw carrying over from the installation in 2019. And most installations are probably not going to be as disruptive as what we did on our farm, trying to, pull a drain plow through mostly saturated soil. One thing that we could always look at in terms of holding back some of that water. If we were concerned about maybe over drying the soil, it's something like controlled drainage. Controlled drainage is really easy on a lift station. That just means you turn it off. You just flip the switch and you turn off the drain tile, and you don't drain if you don't need the drainage. So that's a really easy thing that you can do if you're worried about, you want to conserve any moisture that you have. You can do that, and it's pretty simple. You can do controlled drainage on gravity outlets too, and you can ask me about that after if we have time. We do know that drainage moves downward in the soil profile if it rains. And I think in general, this is not necessarily a negative thing. It's just kind of one of those realities of how that water is dissolving the nitrogen. It's picking it up, it's carrying it downward. What I'm really interested to see looking forward is what happens when we grow sugar beets on this field in 2024. Is that going to be a good thing to have nitrogen lower, or a bad thing, right? We don't know that because we haven't done a lot of drainage on sugar beet ground yet. And last, we did see the higher N loss from our drainage system than just from the air, again, if it rains, because if it doesn't rain and we don't drain, then we don't have any losses that pathway. But I also wanted to make a comment that we are not seeing any evidence at all that this is affecting our soil fertility status. This just seems to be kind of leftover residual N that's leaving. It's not robbing the crop from what it can take up. So with that, that's all I have for today. We are going to keep collecting data on these fields for many more years, and especially thanks to all of our great sponsors that we have and to the small army of people that I have working with me to help analyze all of this data and collect it all. And with that, yeah.
Perfect. If there's any one or two burning questions, we will address that. Go ahead.
Yeah, the question was about planting date, if we were able to take advantage of that at all. And we plant all of this on the same day, so the answer is no, we weren't able to take advantage of that. But what we do have is we do have some soil moisture and temperature data to kind of back calculate and think about, does that improve our trafficability, or is the seed bed warmer in our drained plots? That's something we have been looking at. The other anecdotal evidence I have a couple anecdotal things. When we're out soil sampling, we're trying to beat the planter, and it's a lot easier to sample the drained parts in the spring than it is the undrained parts when we're driving our hydraulic probe pickup out there. So it definitely is improving our trafficability. Yeah.
Go ahead.
Yeah, the question was about, if we're looking at, which elements are we looking at coming from the tile drainage? And we are measuring nitrogen and phosphorus right now. We are thinking about going back and trying to do some salt measurements in the soil, but nitrogen and phosphorus are the two that really are known to move through to tile water, so that's where we're focusing. And I didn't talk about phosphorus at all during this talk, but we actually did see I think some evidence, again, of the soil disturbance in our phosphorus. We actually had we actually potentially had some sediment moving through the drainage system immediately after we installed. But over time, I expect our water to be a lot cleaner out of the drained parts than the undrained parts for phosphorus and for sediment.
With that, we won't entertain any more questions, but if you do have questions, you can get a hold of Lindsay afterwards. Thank you so much.
Yep, thank you.